Or they try to.
Hi, I am Chrono, and this is my cellar. My mentor and inspiration, the Captain Capitalism, has already done a fantastic job in debunking the myth of global warming. But I wanted to add some technical consideration. I'm a techie, and I have looked at the data, so I think I have a few interesting things to say about it. Of course, this video is directed to those who still have a brain and still insist in using it. All the others can stop watching here, because it's not going to be interesting for you. Of course, having a calculator and being able to add and subtract and do simple calculations and simple arithmetics also will help a lot. You know what they say about global warming. We are burning too much stuff. So much that the gases generated by this burning are going to heat up the earth and they will all die. And so we must do something about it. And this something usually consists in taking control of energy production and usage, taking control of all the economic activity, taking control of all our lives. Because this way, using energy usage, basically our governments will be able to control our life 100%, because for anything we need to do, we need energy. Those who claim that the planet is warming will show you something like this, stuff like this. So this is showing an increase of temperature in about 1 degree Celsius in the last 150 years. And of course, they will tell you also that if you do those stop burning stuff, the temperature will go up another 2 degrees in the next 100 years. So that's a whopping 0.02 degrees Celsius per year. So 200 of degrees Celsius per year. And of course, these are scientists, and they have access to a lot of fancy and expensive equipment and all the temperature data. And of course, you can trust them, right? Because if they say so, they must have data showing all this warming. And they, of course, if they tell you that temperature is going up for in the next of 2 degrees Celsius in the next 100 years, for sure they must be right. Right? Well, maybe not. So let's see how all this works in reality. So how do you measure the temperature of a planet? Because it's very easy to say we have measured the temperature of the planet, but actually how this is done? Because measuring the temperature, the average yearly temperature of something, is not that easy. So let's imagine that we want to measure the average yearly temperature of this room. How are we going to do that? So at the minimum, we have to install a thermometer somewhere and take a reading every now and then write down this reading, and then take all this reading across a year, and then do an average. And ideally, we should do this with a method. So perhaps we should measure the temperature every day at the same hour, or we should measure it more than once per day. Or maybe we should install several thermometers, because you know the temperature changes quite dramatically just opening the door of this room. So we will need an array of thermometers, I don't know how to say this exactly, in this room, maybe 1 meter or 3 feet distance from each other, and take readings every hour, every day, from all the thermometers for 1 year, and then store all this data, and then average it out. And so every hour is enough? I don't know. Maybe we should do more, 10 minutes, or maybe less. I don't know, because actually, as I said, this is not such an easy task as someone might think. So, for example, I don't know if you ever used a precision thermometer. I have. I actually have built several, and this is one I built yesterday just to make this video. So you see, is a cheap precision sensor you can buy very cheaply on eBay, and there is a display. So you see, it's showing a temperature. But you know, even putting my hand in front of this sensor will change the temperature. The temperature will start changing because the heat from my hand will affect the sensor. So really, to measure temperature down to hundreds of degrees is not that easy, because a lot of things are going to affect these measurements. So you will think that maybe there are hundreds of thousands of stations with very precise and regularly calibrated thermometers installed all over the planet. And these readings are taken several times a day since 150 years ago, because you know this graph here claims that we can reliably measure the temperature of the planet since 1880. So that's almost 150 years ago. So this interesting data here we will see later. So let's see how the global temperature is actually taken in reality. And let's see if you really think that the numbers coming out of this can be trusted. So how is the global average yearly temperature measured? Of course, we need a lot of stations measuring the temperature. So how many stations there are worldwide? Well, that's the problem. It's not easy to find this information. So I looked around a lot, and there are a lot of different numbers. Also because the stations were installed and eliminated, and this number varied a lot across the last 50 or 100 years. So how many stations there are? Well, let's say, for example, that there are about 10,000 stations in the USA. So the USA is by far the most densely populated nation as far as temperature station go. And there are, so about 10,000, that's about one every square mile. So that's not a lot, because a square mile is a lot of land. And a lot of these stations are installed close to buildings or to roads or close to airports or close to places that will, of course, affect the measurements. And for the rest of the world, the situation varies a lot, because there are actually quite a lot of stations in Europe, for example, in Central Europe. But there are very few in Africa, there are very, very few in South America, there are very, very few in the whole Russian continent, in Asia in general. And there are very, very few on the water, over the sea, and the sea covers about 2/3 of the planet. And also there are very, very few stations on the North Pole and the South Pole. So basically the situation is that there is a number of stations, there are probably about 20,000 worldwide, but they are very differently situated. So the density varies a lot depending on the place. So there are a lot in the USA and in Europe, but the rest of the planet is very poorly covered. Now, not all of these stations can be taken and used to calculate an average yearly global temperature, because many of these stations, they haven't been measuring temperature regularly. Some of them, they have huge holes in the measurements, so for years they haven't been measuring, and maybe for a few years they've measured. So most of these stations, that cannot be really used. So if we take one of the most used data set, the GISS, which is the Goddard Institute for Space Studies, so that's a department of the NASA. So they use a data set containing about 7,000 stations. So 7,000 stations is really not a lot. This is worldwide. That is on average one every 72 square miles. 72 square miles for the metric people, that's about under 70 square kilometers. So that's not really a lot. So these stations are very far away from each other. And in some areas, they are very, very rare. I think there are only 6 or 7 in the North Pole, for example. And the one in the North Pole, they move, because North Pole is just ice floating over water. And actually, this is already bad, but this is nothing compared with what is coming. So how about the data measured by this station? Well, this station measures the temperature in the whole degrees. So they don't measure tenths or hundredths of degrees. They only measure whole degrees. And a lot of these stations, they only measure the minimum and the maximum temperature across a day. So what do we have here? Here we have a data set which contains a variable number of stations measuring whole degrees and measuring only minimum and maximum temperature of one day. And these stations are also at different altitudes, so of course you have to take into account the different altitude, and a lot of other different factors. For example, some stations have been moved from one place to another, because maybe meanwhile they built something where there was a station, so station has been moved. So how do you calculate an average over data that is changing all the time? You know, sometimes there is, sometimes there isn't. It's taking for 3 years, maybe for another 3 years. It's not, and so on. Well, of course, the scientists in charge of all this, they adjust the data. They adjust it. What does it mean? It means that they arbitrarily adapt the data, the raw data, according to consideration, like I was saying before, altitude, or where the situation is located, or the fact that the station hasn't been measuring temperature for several years, because this data set includes 7,000 stations, but only about 3,000 are now in operation, because a lot of stations have been discontinued, have been phased out. So this data is so variable, and then it gets adjusted, and these adjustments are very complicated, very sophisticated. But the interesting point is this: even if you adjust the data, even if you massage this data, and you can come out with a number, how can you calculate a variation in global average temperature of 200 of degrees, starting from data which is measured in whole degrees? So this is my question, and actually a lot of other people have made this question, but they are usually ignored, because scientists, the real scientists, they are doing the calculation, and they are never wrong. Never mind that the salary of many of these scientists depends on the fact that there is global warming, because if there wasn't any global warming, they would be out of a job. But I'm sure that some will come and say, well, if you take all this data, even though it's taken in different places, in different situations, from different equipment, with different calibrations, and some of this data has been measured, has been taken for several years, but then no more, and then a station has been only working for 10 years, from, I don't know, 1970 to 1980, and then it doesn't exist anymore. So this data is all changing. But okay, if you take all this data and you just average it out, you will get a valid number. Well, actually, no. Because this is not random data. Such a consideration would have some merit if this was random data. So if you take random data, you just throw beans over the table, you just pull number. If you take the number of the lotto, this of the bingo, these games where you just pull randomly numbers from a hat. Of course, over a long period of time, averaging all the numbers out, all the numbers come with the same frequency. Okay, you might have a small variation in a limited amount of time, but over a long period, over big numbers, all these numbers average out. But this is not the case for this temperature data, because it's not random. So those of you, I'm only a hobbyist, I'm not a mathematician, I'm not a physicist, but those of you who have formal training in this know this very well. You cannot average out numbers that are not random, because these problems, these stations with problems because they are close to a building or close to a parking lot or close to, I don't know, something that will affect the measurements. You cannot average this out and then hope to get a valid number. No, these data sets are just bad. And the numbers that are pulled out of these data sets are just garbage. They're rubbish. They're nothing. And if you think that our rulers are taxing us to death, they're taxing us blind, and they are removing all our freedoms, and they are launching programs that cost trillions, installing all these wind turbines everywhere, and taxing how I use the fuel, and every year here where I live in Switzerland, they will increase the cost of fuel, of heating fuel, because the Swiss insist in heating up their houses. It's snowing now, by the way. And they insist, of course, turning on the heating, and then, of course, the government cannot reach the goals they themselves impose on reduction of CO2 emissions, so they will increase my heating bill because I keep heating my house. So this all is ridiculous, and it's based on a scam, because all this is a scam, folks. These numbers are absolutely worth nothing. It's rubbish data, and the numbers pulled out of this rubbish data is just rubbish. There is no way, there is no mathematical or statistical or physical or any other method that can transform rubbish into good numbers. So this should close. There should be no discussion really about this. All this stuff they keep throwing at you in the form of graphs and charts and this and that. It's just garbage. And you know, the only real good way to deal with someone who is coming to you and saying, well, you know, the temperature of the planet is rising, you should just smack them in the face. Because really, this is bullshit. All this is just fracking bullshit. Fracking bullshit. This is garbage. And there should not be no discussion about this. This is just global scam. And anybody in his right mind should understand this straight away. So, yeah, I think this video is already too long, but yeah, please look at the data, look it up. It's all online. You can all find this data online. You can build a precision thermometer with just a few dollars worth of electronic components you can buy over eBay, and then you can start looking. You can start seeing how difficult it is to just measure an average temperature of anything across a year. And all these people is coming, oh, you know, this year the temperature of the planet will raise of 0.02 degrees, and so in 100 years, that's crap. That's, yeah, bullshit.